Good morning, guys. I'm going to make another video presentation about zone allowance calculation. So let's begin, guys. So it is a continuation with the zone allowance calculation. Now this is now example 5.5 and the same vessel, Nara. The next voyage is to load full at Coquimbo. Coquimbo is in Chile for discharge at Longview, Washington. Basis of loading calculation. Okay guys, where is Kimbo? Kimbo is in, this is Chile. This is in Kimbo. So it's in South America and this one is Argentina and the other side is Chile. So this is Kimbo and Washington is Longview. Longview, Washington. This is the discharge port. So from here, South America, go up and go to Longview. Okay, and these are the parameters. Loading port is Chile. The zone is tropical, and the density in Chile is 1.025. Now this discharge port is Longview, Oregon, and it is a summer there. The load lines of summer, and the density is freshwater of 1. These are the ROBs in departure in Kimbo, FO 735 DO 35 LO 15, and freshwater 150, ballast is nil, and constant is 180. This is the consumption uh, of the voyage, which is laden, meaning loaded. So the consumption FO per day is 25 metric tons. Diesel oil per day is 1 metric tons per day. Production of freshwater is 6 metric tons a day, and freshwater consumption is 12 metric tons a day. Meaning, your you are you have 6 more metric tons of consumption per day. Okay, which means disregard the production because you have more consumption here. And the speed required for the steaming time is 40 knots. From Coquimbo to Longview is 5,604 miles, nautical miles. And you have Kimbo to 13 north is 3,254, which is this one, guys. This boundary of 13 north. This one. This is the boundary. Okay, let's put on the other side. This one better. So this is Chile, somewhere around here. So it's in a tropical zone area, and the boundary of summer is, if we travel here in the summer zone, this is the boundary, probably this one. Okay, So check on the other. Summer zone is here. So it travels along the coastline of the US, and this is probably 13. This is 13. 13. This is 13. So boundary of summer says 13. This is 30. This is 15. So a little bit down here. So this one, 30 north. So from Chile, this is the boundary of 13 north. So when he passes this area, this is already summer zone. So 13 is here. So that is what it meant. I'm sorry. The Kimbo to 13 north latitude, which is 3,254. Again, let's see the. So you see here, this is the 13th north latitude. So Chile in the tropical air zone. So when it reaches the 13th north latitude, that will be summer. Okay, from this area. I hope that's clear. And then we go to the next. I'm sorry. Go up. These are the questions. Find the displacement of departure loading port, meaning in Chile, sa Coquimbo, the maximum amount of cargo to load. How much are going, what is the maximum cargo to load? The maximum permissible sailing drop. So if you have this cargo, what will be your sailing drop in Chile? Assuming that the load port is the local density of Coquimbo is 1.009 tons per cubic meter. Cubic meter. Find the maximum permissible drop. What will be the drop if the boat is sailing at a density of 1.009? That is what it meant here. Assuming that it's about to complete loading, loads at a drop of 9.34. Okay. So from this drop of 9.34, he's asking how much remaining cargo to load for completion. Take note that here he's asking for the maximum drop or sailing drop. So from your sailing drop minus your present drop of 9.34, then you will know how much cargo remains to load when she's floating in a density of 1.009. Take note that at the departure drop is density is 1.009 and the presence drop will be 1.009, meaning they have the same density. Okay. Now the solution. Identify the different zones of the voyage. Identify the governing zone. Calculate non-total weights to be deducted from the dead weight and calculate the zone's consumption allowance to be added to the zones. This is the solution. These ones are all the ROVs remaining on board. So fuel oil, diesel oil, log oil, freshwater, and constant, which is this one, guys. This ROV and this one. Okay. And these are the consumptions per day during the entire voyage. FO is 2.5, DO is 1 metric tons, and freshwater is 6 tons, which is this one. Consumption. Okay. Okay. Then steaming time is 9.7 days, meaning if we calculate, if let's see the question. Okay, from Coquimbo to 13th north latitude, the distance will be 3,254. Divided with 40 knots, then the answer would be 9 days, 9.7 days. Okay? Again, divide 3,254 divide with the speed, then you will get 9.7 days. Okay? And if your ROB is 735 minus your 25 consumption per day, excuse me, with the entire voyage of 9.7 days, multiply with your daily consumption, total consumption will be 242.5 metric tons. Total consumption from Kimbo to 13 North. Okay, that's what it meant there. Again, your daily consumption of 1 ton multiplied by the number of days, then you have 9.7 metric tons consumption of diesel oil. Now, freshwater, you have a daily consumption of 6 tons, but you have a production of 12 metric tons per day, meaning you will have 6 tons 6 tons consumption per day. So 6 tons times 9.7 days will be 58.2 metric tons. So with this consumption minus your 150, then you will have 91.8 remaining. The total consumption of the entire voyage is 310.4. This will be your zone consumption allowance. Okay? This will be your consumption zone allowance. Okay? And this is the ROB when you reach the borderline of 30 north. 30 north latitude. So when you reach this point, or when you reach this 13 north latitude, which is this one, your ROB will be this one, 804.6. Okay, and here's now the manual computation. We have the same here, and this is now the manual computation. But anyway, I made it my own, so it will be much more clearer. And this one, it's the same. And I'm sorry. And here you have the same Coquimbo 13 north latitude. Okay, and this is now the question: the displacement at loading port. So what is the displacement of loading port? Because you are in, excuse me, the question. What was the question again? Here, the question is, identify the different zone of the voyage from tropical to summer, meaning from Chile to Longview, Oregon. Longview, I think that would be Washington, not Oregon. Identify the governing zone. The governing zone to use is summer. Okay? So, summer, your vessel, what is the summer drop of your vessel? Okay? The summer drop of your vessel is summer drop of your vessel. The displacement is 30884. Okay? Take note. The summer displacement of your vessel is 30884 and the drop is 9.550. Okay, let's check. Oh, sorry. And okay, the displacement of the departure loading port is summer drop, which is 955, which is 31588. Why? Let me check, guys. Okay, this one. The displacement at governing zone is 9088, 90884, summer displacement. Check again. Correct? 30884, and that drop is 9.55. Okay, that's correct. Plus your zone allowance, which is 310. This is your zone allowance. Your total consumption from the entire voyage from Kimbu to this is north, or shall we say north, put here north, 13 north. Okay, that will be your borderline. Okay, so from Kimbu to 13 north borderline of summer drop, your ROV will be let's say this, put it this way. And so this will be from your borderline of 13 north. Your total consumption will be 310 and your ROB will be this one. But we are concerned only on this consumption, which is your shore allowance, zone allowance. So here, you put down your zone allowance, you add this one, this will be your true displacement departure of 31198. So what is the drop of this 31198? 31198. We go to the hydrostatic table, 31198, 31198. Is that correct? 31198. 194. 31194. 10. Your drop is 9.638. Get there. 9.638. Okay. You put this one 9.638. So you got here 9.638. Okay. Then minus your light ship or light displacement of 6772. Your light ship or light displacement is 6772. Okay? And your dead weight will be 24422. Okay? It's a little bigger. Okay. So your dead weight will be 24422 minus your weights on board of 1115 or remaining on board, which is this one, guys. Your departure from Coquimbo, your ROB remaining on board is 1115. Okay, which is this one. And your maximum cargo to load is 23307. Okay, that will be your maximum cargo to load. Again, we will try to answer this one. The displacement departure uploading port is 31588, which is this one. Loading port. What is the summer? Excuse me. 31 departure drop. So this should be, let me check. Departure was 31194. 31 departure displacement at loading port. So 31194, 31194, and the corresponding drop would be 9638. This should be 9.638. 9.9 how much? 9.638. 9.368. Correct? 9.368. Okay. That will be the displacement at departure at loading port. And the total amount of cargo to load is 23307, which is this one. Okay? And the next question, the maximum permissible sailing drop. This will be the sailing drop of 638. 638. Okay? In number 1, he's asking for the displacement, which is 31194. And number 3 is asking for the sailing drop, which is 9638. Okay? In the summer zone. Or this is the departure displacement. Departure drop. Let's say departure. This should be departure drop. Okay. Departure. Okay. Same. That's right. Just make some corrections, guys, because there's some error. Again, displacement of departure loading port. So the displacement is 31194 because from your summer zone of your vessel with the displacement, you add your zone allowance. Those will be the true displacement of departure. Okay, so here, which is 31194, which is asking the question of the displacement at departures. This is the one, 31194. And the maximum amount of cargo is 23307. 307, and the maximum ceiling drop is 9638. Okay? Now, assuming that the density at loading port in Kimbo, the take note of the density here, but in the loading port, the density is 1.009. Find the maximum permissible drop. So what will be his drop if he's floating in a 1.009? Okay, from this saltwater drop of 9.638, what will be her drop if she floats in a density of 1.009? And this would be your drop in brackish water. So let's check, guys. Here, your displacement of salt water at a drop of 9.6. This is salt water, guys. This is salt water. SW. Okay. This will be salt water displacement. So to get the drop in brackish water with this salt water, the formula is brackish water times I equals true displacement, which is 31194 times 1.025 of seawater over your local density of 1.009. And the answer would be 31688. So what is the drop, corresponding drop of this one of 31668.65 is 9.77, which is this one, guys. But anyway, this is the one solution, but I will show you another solution. Okay, and we go to 7. Okay, so your present drop present density was 1.025. Okay, and the drop was 9638, 9.9638. Okay, 9.638. Okay, 9.638. Okay, look at the displacement, 31195. Displacement is 31194. Okay, then take out the cargo, and what will ship load if he is in a density of 1.009? 1.009. His displacement will be 31689, and look at the displacement here, 3168865. You round it up, that will be 31689, which is the here, and that corresponding drop, mean drop is 9.778, and the mean drop is 9.78 runoff, and they have a zero deflection. And this one, round it up, that will be 9.78. Okay, but I have another I have another solution. I have another format. Aside from this one, let me check, guys. It's not here, so I have to take it out. And let me see. This one. Sure. Okay. Take note, this one is salt water to duck water. Okay. So this displacement was 1911194. Check. 1994. Okay, you put this 9 point. 19194, and drop is 638. Okay, 638. The local density is 1.609 and standard of salt water 1.025. The formula is displacement times salt water times dead duck water or brackish water. Put this, we call this duck water or brackish water. Thus the formula is 31194 times 1025 and 1.09, which is the same with this formula. Okay, and scroll down, you will have a displacement of 31689. 31689, which is 31689 or 688.5. Okay, 689, 31689, 31689, 31689, and that will be, your drop will be a 9 point, how much? 9.31689. Okay, put this 31689, 31689, 31689. That will be 9.778. Okay, put 9 point. How much? 9.778. 778. Okay. Okay. So here you have about 9.777, but in the other is 9.778. Take note, guys. Here, this is salt water to duck water, and here from click this one, and here you have duck water to salt water. Okay, so the displacement in duck water is 3168865, which is this one. You have the drop of 3168865 is 9.778, which is this one. Your local density of 1.009 and standard of 1.025. This is now the reverse. Instead of salt water, you put duck water. Instead of duck water, you put salt water under. Then you do the equation. and your salt water will be 91114, which is this one, and your drop will be 9.638, which is the same with your drop here, which is in salt water. And take note, guys, I want you to see this one. When in brackish water, your drop is more deeper, or your more sinkage with your drop of salt water of 9.638. Okay, so in salt water the vessel will float, and in dark water the vessel will sink with a drop of 9.778, and your displacement is more than your saltwater displacement. Okay, so take note of that. When in salt water the vessel will rise, that's why you have a more drop here with 9.778. If this is your saltwater drop, you go to your dark water drop or brackish water, the vessel will sink. That's why you have a more drop here. Okay, and so assuming that is about to complete loading involves at a drop of 9.34 on dark water density of 1.009, find how much more cargo she can load. The answer to me is 1532. Okay, we'll check this one, guys. Answer is number 5. So in number 4, assuming the density of loading of 1.09, find the maximum pressure drop. So this is your drop at brackish water of 1.09. Again, the vessel is floating in salt water. What will be his drop if his density is, or the vessel is floating in a density of 1.009, and this will be his departure drop of 9.77 in brackish water or in a density of 1.009. And here is asking what will be the remaining cargo if the vessel floats in 3.34 metric tons in a density of 1.09. What will be his remaining cargo to load? So 9.34. Take note of this ceiling drop, guys. 9.77. We go to 3 months only. 7. Okay. Go to the program to use, guys, is how to find trim when handling several moderate weights. Okay. So the question says your drop would be when she stop loading. Okay, repeat again so that it will be clear. So the vessel stops at 9.34 metric tons, and the foreman will stop the loading operation and will ask the chief officer of how much remaining cargo to load. So he has to compute. So with the chief officer and the drop surveyor will go down around the vessel and take a drop readings, and after several minutes, they both agreed that the drop forward will be 9.34, and the drop up will be 9.34. Okay, and their actual midport is also 9.34, and the starboard midship drop is the same, is 9.34 no lease, no trim. Now our sailing drop with a density of 1.009 when you take the draft, and your sailing density would be 1.009. Okay, and our sailing drop is 9.777. Okay, this is the maximum permissible drop when you're floating in a density of 1.009. Okay, for the sake of computation, we put 9.777. Okay, let's just put 9.77. Okay, now the recommended cargo to load is 1,532 to be exact. So how did I get this recommended cargo to load for trimming? This is the formula, guys. K8, which is K, and 8 is your sinkage, and M3 is your M, row 3 is your TPC times 100. Okay, so again, to get the remaining cargo to load is K8, which is your sinkage, times your TPC of M3, which is 35.62, times 100, then you will get 1,531.6. Now, your sailing drop is 9.77, okay? From your final mid drop or sailing drop, you interpolate the TPC of your sailing drop, which is, and you get 35.62, which is this one. So you always have to get the interpolation of your TPC of your sailing drop. Now you have your sailing recommended cargo to load is 15331.2. Again, we have here a solution. Your remaining cargo to load sinkage times TPC times 100, that will be 0.43, 0.43, and your TPC of 35.62, 35.62 times 100, then you have a total of 1532. Okay, that's clear. Now, the question or the question stops here, stops only here. Okay, only to find out what is the remaining cargo to load. And here is another solution. It says identify the different zone of the voyage, that is tropical and summer. Tropical is from Coquimbo, and summer is the Longview or Washington. And identify the governing zone is summer. Okay. Calculate the non-cover weights to be deducted from the dead weight, which is 1,115, which is this one. Oh, sorry. 1,115. Okay. and calculate the zone consumption allowance to be added to the limiting zone, which 310.4, which is, sorry, which is this one, total consumption. This will be your zone allowance. Okay? Now, the problem stops here. It's asking for the how much cargo remaining to load for trimming or remaining cargo to load. But I will extend the solution and we try to trim this cargo to two holes. So from there, what happens is we load this figure. So I put it 1532, and when you load 1532, what will be the result of this drop? So the source after loading 1532, your mid drop will be 9.77, which is the same with your final drop, and your sinkage is 0.43, which is the same with your sinkage. Okay? Now, according to the program, then go to trim two holes. So I go to trim two holes. Take note of the remaining cargo to load. Okay? That will be trimming two holes. Okay? This is your initial drop of 9.34 forward, 9.334 up. Okay? Then here you have your remaining cargo to load. Now our trimming hold is 1 and 4. Okay, put here 1. You put here 4. Okay? The yellow cells, that's where you edit the figures. Then you go down. They say I don't want a trim. You put 0, no trim. And how much would you load in hole number 1? So in hole number 1, you should load 626. So I load here 626. 626. And how much are going to load in number 4? That will be 906, which is 906. And what will be your departure drop? Departure drop forward will be 9.77. Your up drop will be 9.77. You have 0 trim, and your main is 9.77, and you have a 0 deflection. Okay? Again, I would always say that this is a very good program because not only you get your target drop of no trim and your deflection is 0. Okay? So I just put it this way. Take note of number 1 of 626. Number 4 is 906. We go back to form 6. Okay. From the start, take note that at number 1, you're going to load of 626 and you're put it here and you have your LCG, and number 4 will be 906. Number 4 is 906 and you have your LCG. Then your departure drop forward will be 9.77. Up drop will be 9.77. You have 0 trim. Your main is 9.77 and you have a 0 deflection. Okay? You have the same drop here, same drop there. Then we go by trim table. Okay, we go by trim table. You have the same cargo of 1532. In number 1, you load 626 and number 4, 906. Now from your loading manual upward, check your correction and up correction in hold number 1. So take your trim table from your loading manual and check the forward and up correction of hold number 1. Now, assuming the correction in number 1 forward is 9.0 and up correction is negative 0.7. And hold number 4, the forward correction is negative 1.5 and up correction is 5.2. Once you fill up these figures, your departure drop would be forward 9.77, up drop will be 9.77, your main drop is 9.77, mid is 9.77, even kill, and you have a zero deflection. Okay? Now, there's another solution of using a trimming table. Okay? In this case, you're going first to load in hold number 4 because you want to have a good trim. So the amount of cargo to load in number 4 will be 906, and the forward correction is negative 1.5. Same here. The up correction is 5.2. Same here. Once you have completed loading of 906 metric tons, then you will have to load in number 1. In number 1, you have to load 626, which is same here. Your forward correction is 9 here, and your up correction is negative 0.7, and same here. Okay? Once you have completed in load number 4 of this cargo of 906, this will be your initial drop of 9.20 and 9.81. This was your previous initial drop of 9.34 forward and 9.34 up. So once you finish loading, carry this one, then you're now ready to load in number 1. After completed loading the figure of 626, this will be your final drop forward of 9.77, an up drop of 9.77, and your trim will be 0, and main drop is 9.7, and you have the same of 0 deflection. So, let's put this way, guys. All you have to do is this yellow cells, this is where you have to edit, okay? And all the rest will follow. Then we go to Form 7. Form 7. Then the water density at port is 1.009. Okay? The initial drop was 9.34 forward, and up drop is 9.34. Okay? Then how much are we going to load in number 1? 606. Number 1 is 626. Load 626. Make it positive if you're loading. And number 4 is 906. Okay? 906. 06, and your final departure density is 1.009, and your mid will be 9.77. 9.77, but here that is almost even killed, but here you have a trim of 0.2. But anyway, that's you have this trim because of the complex of computation from each program, but you have here a 0 deflection. So again, the drop by trim table computation, your drop is even kill of 9.77, and trimming 2 holes, your drop is even kill of 9.77, and here your drop is 9.77. So you have 1, 2, 3, 4 programs to back you up of your computation to get your sailing drop. Okay. Now let's go back to the question or problem. So here you have 15.32. But here I made another solution. Your present drop was 9.34 of salt water and your departure drop is 9.77. So this will be your sinkage, which is this one, sinkage. Okay, sinkage. Sinkage is 0.43. Okay, then you will have this one, sinkage. And you put your this is your displacement in brackish water of 9.34 and your 9.77 of displacement in brackish water is 31168, and you have a remaining cargo total of 1444. If you are floating in a salt water, okay, your displacement for 9.34 will be 29674. Salt water will be, if you convert this to salt water, this will be your drop and this will be your displacement. If you convert this 9.77 to fresh water, this will be your drop in fresh water and this will be your displacement. And your remaining cargo to load will be 1420. And here you have the same sinkage. So what I did was just convert it from salt water to brackish water. Again, this drop is from brackish water, this drop is from brackish water, and this drop, this will be the displacement, and this drop will be the displacement. Then you will get the remaining cargo to load. And from this drop, transpose this to salt water drop, and from this drop you convert it to salt water drop, and these are the displacement for each drop. Then you have the remaining cargo to load. But what I did was using this formula according to my program. That's why you get remaining cargo to load of 1532. So I would rather use this program in getting the remaining cargo to load, which is this one. This is another way of finding out the remaining cargo to load by using the dock water density or using the salt water density. But I rather use this one. For me, it is more accurate. Although they have the same means of you getting the remaining cargo to load, but I would rather use this one. Okay, and let me see. Here, we have another method here, but he's using the TPC. He's already interpolating the TPC, which I don't recommend. And here's another method here. This displacement method. So you use the present displacement and target displacement. This is in, I think, brackish water. Okay, using the brackish water, and recommended cargo to load is 15.21. Brackish water. This one, salt water 15 to 1. Okay, That's why he got this figure of 15 to 1. 29673, 29673, 29674. Okay, so this is what he's been trying to use the seawater displacement, and you get 15 to 1. But I would rather use this one because according to the formula, this is what it says. Okay, so that's it, guys. I hope you would like this video. If you like, please click the like button, share, and subscribe. And please don't forget to click the notification bell. Okay. I was trying to think of another. Let me see. Trim table. Okay. That's it, guys. So have a good day, and thanks for watching.